Good afternoon. This is Vlog entry 133 in Carolina. It is about 1:30 p.m. CST. I have been doing my normal thing in the morning. I had to go to the grocery store to get a couple of things, and I got myself some fruits because I typically have fruits at home, but I had bananas and whatnot, and I got myself a little container filled with pineapples and sliced strawberries and whatnot. So I decided to get that, and I just like having fruits in my house. So I went over there. I also had to get a couple other things and whatnot. So I did do a grocery run today, and it was actually a lot slower. But because it was about 1:30, and the other time I went to the grocery store when it was actually extremely busy, it was about 12, and that was still during the weekday. And for some reason, my brain was thinking, like, well, I mean, was this a Monday? I think it may have been a Monday as well. So maybe they just wanted, maybe people like right during lunchtime tend to go to the grocery store to get that out of the way if they decide to. Because usually, I think the common pattern is they typically save their grocery days for Sundays, because Saturdays are just like they're completely off days, and Fridays are obviously, they don't want to worry about that. So you get people on Sundays and Mondays actually doing that, and for Mondays it's typically during lunchtime, so they can just get out of the way and not worry about it for the rest of the week, I guess. I'd assume that's probably the best explanation of why that was the case. I didn't think about that earlier, and I don't think I've been there on a Monday. Maybe I have, but I didn't think about it. Oh God, Tinder keeps sending me messages. I was getting on Tinder. I actually get a lot of likes because I consider myself to be a fairly attractive person. I get a lot of matches. I mean, some of them are bots, of course, and whatnot, but I still have a childlike face though, so maybe people like that. I don't know. I don't have a manly face. Well, the picture I have now is it's kind of nice. It's kind of nice. Oh. Yeah, it's a nice picture. Yeah, I had my name on there, but whatever. I think it's a nice photo. I'll show it again. It's my Tinder. That's me. I actually look good in this photo. I usually don't have good photos of myself, but this one I actually look good in. Yeah, so... yeah, so I've been... Again, like I said, I've been doing my typical thing, and... I was everywhere again, sort of. Okay, it's a little bit more the focal point of what my endeavors are in is mainly around linear algebra for the time being, because I just had to brush my shoulders off from the lack of practice I've had, because again I just have not been doing any kind of mathy stuff, and I think although there are ways in which you can intuitively fly over a lot of these abstractions that physicists use. I mean, of course, physicists tend to do that too, because a lot of them are way ahead of mathematicians when it comes to being able to define quantum field theory rigorously. And well, the biggest thing is because, well, they had to use computational methods, because not fields tend to not be completely differentiable and analytical completely. Not the actual world. I'd assume that they're trying to model it as close as possible, so the best way to do that is using computational methods and whatnot. I don't know what kind of computational methods they do, but that's probably the best reason why they just can't wait for mathematicians to define all this stuff rigorously, and they tend to go over infinitesimals quite a bit too, without really explaining it really. Like Feynman, when you think about a particle having an energy, this particle is considered to be quote unquote point-like, even though, again, I think Feynman is a smart guy. He's a smart guy, but also I think his perspective of it was skewed, because I guess back then, of course, you're more likely to think about things from a Newtonian perspective, but I think people still are not realizing that it's just not going to work like that anymore. It's not going to work like that. The closest to a particle you can get is a point on a... Like, the thing is, like... I don't know. It seems like experiments have shown that these are not particles. They're not particles. They're not billiard balls anymore. They're not infinite. They're not point-like... I mean, these quote-unquote point-like objects are something I have a name for. I wouldn't necessarily say it's like a rigorously defined definition, but you can give these DAs, these small, I call them DAs because I'm looking at a two-dimensional field. It would be a DV in 3 dimensions, of course, when we're talking about space and whatnot. And yeah, so these DVs just have, these are like nodes. You can think of them as nodes on a field and whatnot, and you could think of like a blanket. Like imagine a blanket, and from a macroscopic point of view, you don't realize it's just a bunch of atoms that are covalently bonded together, right? Of course, there are like threads around these, and maybe you could think of it like that because it is gridded. I think, you know, you had to like these I guess these threads are wound together up and down and whatnot, so you can almost think about it as like a grid structure of some sort if you go in microscopically. So you can think of fields like that too. Yes, there's going to be a discrete structure, but I mean, we can only go so far. We can't just keep zooming in on a field, right? Obviously, that doesn't make any damn sense. Like, how does that make any sense? How would that be even practical to any sense? Even in the mathematical sense, we can't do that because we use infinitesimals. Like dx's and dt's are not actually zero, but they're approaching zero and asymptotically approaching zero. They're not zero though. Of course, it can't be zero, but yeah, so I don't understand why physicists are still doing this and why they have to quote unquote whatever this, they call it re-normalization and whatnot, and maybe I just have a wrong depiction of what it is, but I personally think particles can be seen as like these nodes, and then each of these nodes can have contact points of different fields, and like, you know, if you think about the magnetic electric field, it has these nodes, and these nodes are imposed on by the magnetic field. That's why you see dipoles, because this magnetic field is also it's not a change of force. Maybe, I mean, if you look at a very small dt, it is a change, and it can just appear, but maybe it can just appear. I don't know. It's like, how are we supposed to know that? I think it does, because this is also outside of the span of time. This is not within like these objects that are imposed on the electromagnetic field are not within within time. They're just outside of time and space. And then, you know, you get a lot of people talk. I don't know if there are a lot of people really talking about like how these can be abstract into a linguistic point of view for fields. And I like to think about, I don't know, when I think about a one-dimensional plane, I think about these nodes, and these nodes have you can think of them as God, basically. Anything that can't be explained from our current understanding is basically we can perceive it as God because we don't really know what it is. So this object has a language. You can think of it as an input-output node for a one-dimensional field. This node would have one input, which is the magnetic field imposed onto the electric field, and then this object that has that imposition of information is going out in three directions. Yes, it's going out into the terminal space. You know, you can think of it as like a screen, or you can think about it as reality as we see it. This is the unseen. This is the stuff that we don't see. It goes out into terminal space, and it goes out to its nodes adjacent to it. This is a one-dimensional field, so it would have three outputs. And then these nodes would also have three outputs, and each and every other node would have three outputs, and they would also interact with the quote-unquote terminal space. I feel like I was somewhat inspired by Chris Liggett, so I do have to give him credit for that, because he does explain it pretty well and whatnot, and that is a great way to see it from me. He likes using fancy words. It doesn't have to be that fancy. He doesn't have to be that fancy. I don't know why he has to use very quote-unquote big words. And then I think he's also invented his own language, so it makes it even more exclusive to him and nobody else. So it's kind of silly in my opinion. He calls it geolinguistics. Basically, it's like, I mean, don't we already do that enough in physics and well, maybe not mathematics. We tend to mash words into a compound, like, you know, the electromagnetic field. I guess it's a good way to see it as, because it is, they're kind of like they have like a dual relationship to a degree. I mean, yeah, they have a dual relationship. So I guess that's why he likes to use the same patterns that physics uses. But, you know, it's cool. And I think some people are going to get confused by the big words that these guys use, because it's a form of gatekeeping to some degree, because you have to, like understand what they even mean by it, and then they create all these these abstractions in their heads that have definitions to it, and they have to explain it to the layman to what it actually means. And it's good to do that, because as long as we're all on the same page. I think what really matters is that we're all on the same page, as opposed to trying to make your language exclusive to yourself and nobody else's. Like, why how does that really help out with anything in this world? So again, like, no hate on him, but still. So I guess I am inspired by him to some degree when I think about fields, because I do think of it from a quote-unquote computational perspective. There's an input, 3 outputs when it comes to one-dimensional fields, and then when you think about two-dimensional fields, you have to think about squares, and then these squares have 4 outputs. There's an input, and then so that would be 5 outputs, 1 input, 5 outputs, because of all its adjacent things, and it goes up by, you can think about it as squares, basically. So one-dimensional, the pattern is, when it comes to output, it's just 2 to the power of n, so times the dimension. So the dimension of a field is 1 times 2 to the power of, n times 2 to the power of n would be the best way to say it. Or just 2 to the power of n, sorry. Yeah, because we're looking at one-dimensional and all that. I don't know why I was trying to put a coefficient for it. It's just 2 to the power of n. My brain's being silly, so I'm like kind of out of practice when it comes to math, but that's the common pattern. 2 to the power of n plus 1. Sorry, I forgot to add the plus 1 to it, because there's a third, which is the display, the quote-unquote display, you can call it that. It has an output towards it's a scalar representation of the field and whatnot. So for that particular quote-unquote infinitesimal point, whatever you want to call it. But yeah, it has a 2 to the power of n plus 1 output. The n is the dimension, so you have to think about it like that. And it's commonly seen as not big N but small n when we talk about dimensions in physics and mathematics. It seems like that's a common notation that we use for it, even though n is used in multiple other cases. It just happens to be, so that's just how we abstract it, I guess. So again, you get about 3 dimensions. It's the same thing, right? You think of a cube, 6 sides, right? That's interesting, actually. Now that I think of it, it's like, wait a second. Oh, am I thinking about this wrong? No, I'm thinking about space. Sorry, my bad. It's still 2 to the power of n, I think, plus 1. Is it 2 to the power of n plus 1? Let me see. Yeah, I think it should be 2 to the power of n plus 1. My brain's not working right now. Because then it becomes a 3-dimensional object. So I guess that's interesting, though, because this 3-dimensional object tends to have 6 contact points. So I was wrong. It's actually just 2 times n. It's not a power representation. That was my bad. It's 2 times n representation. I assumed it was 2 to the power of n because I looked at I was being short-sighted. Sorry. Yeah, it's 2 times n, not 2 to the power of n. That was my bad. And then, like, of course, you can start thinking about other dimensions and whatnot. But these objects, so 2 times n to the power of 2 times n plus 1 represents the amount of outputs that these quote-unquote objects outside of how we perceive space and time have. And it always has 1 input, I think. It's always have 1 input. Because I'm thinking about, like, the input is like does it always have 1 input? Yeah, there's always 1 input. Yeah, there's always 1 quote-unquote information input. Because, like, you can think about the electromagnetic field in 3 dimensions and or 2 dimensions or 1 dimension, but they all have 1 input. Because then you can look at all of space, and then there's an input from the magnetic field to that particular quote-unquote dV, dA, dx. That's just like a degradation of dimensions. I just how to envision it, because these objects are not zero. They're not zero. That's the thing we have to keep telling ourselves, is that they're not zero. And they may not even necessarily be approaching zero. There's another thing. Maybe they're just a really small constant. Like, isn't there like Planck's? There's like Planck's energy and Planck's distance and Planck's time and all that. So I think they already have figured that one out. So that's also another thing that I'm confused about. It's like, okay, so if there's these Planck scales, and wouldn't these particles also be coinciding with that to some degree? So that, again, I don't know. I have somebody calling me. maybe they'll leave me a voicemail. I don't think it's any of the important numbers that I'm looking for because, fuck, if it's IDES or, oh no, because I really hope it's not ABE because, shit. Give me a second.